Hey, what's going on, internet? So, a lot of people are talking about MCP and the associated revolution that's occurring with AI agents and MCP. But very rarely do people talk about the problems with this technology. There are many issues, but the primary one that I've come across many times is reliability. If you're lucky, your MCP agent will fail 20% of the time. But on an average day, it's probably around 50% of the time. And like I said, this is just one of many issues. Now, if you're serious about implementing MCP in your business, you should watch this video first. Because the truth is, reality is way different from what the hype machine is selling you today. With that being said, let's jump in. Alrighty. As always, we have ourselves a beautiful image of what OpenAI's GPT-4 image gen perceives AI having troubles using tools. And this is our AI in the ancient and Greek era. Before I get started, I want to give a quick disclaimer. So I'm obviously a huge fan of AI. I think about it and research it all day, use it all day, and work with it all day. And I myself have built many MCP servers, and I have deployed many MCP servers, and I use them quite often. The important part about this entire video is that the disclaimer and the issues that we're having are today. So if you're trying to deploy MCP servers in production today for your business, there's a lot of issues that you're going to run into, and it's likely not the best route for you to pursue. In 6 months, that may change. In 12 months, that likely will change. But it's important for us to be grounded in reality when we're implementing these things in production for businesses that are operating. With that disclaimer out of the way, now let's get into the details. So there are, what are there? One, two, three, four, five or six points I want to make here. And it should be a quick, pretty short video. All right, so first things first is when to use the MCP. So this is a question we should ask ourselves. This is always the question you should ask yourself for anything you're implementing, but we'll ask this one now. And the answer may be sad for most of you, which is rarely. Rarely should you use MCPs in production today. And I have a little test I like to deploy when I'm having conversations with people is a Friday afternoon test. And the test is simple. You ask yourself, would you deploy this MCP on Friday afternoon in production? Do you have that much trust and faith, both in the MCP itself, but also the guardrails and infrastructure you have around it? Oftentimes, the answer is no. And if the answer is no, don't use MCP. Use code instead. But if the answer is sure, yeah, I'll give it a try, then you need to consider a few things. And those few things we need to consider here are going to be these questions. So, first and foremost, can it fail without catastrophe? So, is it okay for this thing to fail? Because it will. And if it can, that's good. And here's some examples. So one is if it's drafting an email that's being drafted and the human then approves it before it's sent, that's a good example. If it's processing payroll, definitely not. That's a critical thing that we don't necessarily want to outsource to AI, at least not yet. The next question is there a human checking the output? Very similar to the failure. So if it fails, then we should send it to an AI, to a human, not an AI, to validate the output. An example is if the AI writes the email draft, it's reviewed by a human before it's sent. And then also another one is if anything is around auto execution of deleting or doing some sort of action that's critical, you probably don't want to do that. And then our last one here is am I solving something fuzzy that keeps changing? Now, this is probably the most relevant question for the usage of MCP is the specific thing you're wanting to implement in this automation, does it have some sort of adaptable context where it's always changing based off the conversation, different variables, etc.? If so, that means it might be more susceptible to MCP, but not necessarily MCP is the answer. So an example here is if you're getting customer requests that are always changing, that might be a good use case if they're changing without any sort of theme or variable. If you're doing tax calculations, probably don't want to use MCP, at least not yet. So let's say that you've answered yes to all these questions. Because if you've answered yes to all these questions, then you should move to the next phase, which is accepting the fact that your MCP likely will fail 20 to 50% of the time. That's even with the best models today. And if that's not okay with you, which it might not be okay with some people, then I'd recommend just waiting 6 months. Reason being is the models are getting a lot better at calling tools more effectively. And also the reasoning happening in between the calling of the tools is increasing their ability to call the right tool at the right moment. So I wouldn't be surprised if in 6 months, maybe even less, the model's accuracy for tool calling and the use of MCP increased drastically. So I want to give you some examples of what are some good examples for MCP, what are some bad examples for MCP. So these are good examples. On the good example side, we've already talked about this. So if you're drafting response to varying customer complaints, so this is very similar to drafting emails. If the AI is drafting something in response to something that changes consistently, then it's likely a good use case. Now I'll jump down to the third one here because it's similar to the first, where we're handling unpredictable user questions that are coming in from a chat. So we're responding to an adaptive thing that's being asked of us, and then we're responding with an answer, or we're drafting an answer that and the human then validates. And then our second one here is like kind of a deep research use case. So you're basically doing research, pulling out a variety of documents that are relevant to a question. If the requirements are always changing, then this is likely a good use case. And then what are some terrible use cases? So basically anything that's critical. So the TLDR here is that if it's a critical use case where you're deleting something, if it's critical for your business, your brand, etc., you probably don't want to use MCP, at least not today, without guardrails. So processing payments, no go. Updating medical records, probably not. Executing trades for investing, bad idea. So those are some bad examples and good examples. So that's the first thing we do is the Friday afternoon test. Next is going to be the 4 rules for building MCPs. So if you decided to build MCPs and that was a path you wanted to take and it's outside, now it's important to note that this is not doing something for yourself locally. So there's a lot of developers that are building MCP servers for themselves on their own machine or a prototype they share with their friends. But this is something that's in production for your business. So if you're doing that, these are 4 rules you want to follow. So our first rule here, avoid the tool trap. Oftentimes I'll see people adding to a specific AI agent, one agent, 20, 30, 40, 50 types of tools that the AI can call. And some AI models can deal with that if you've structured it correctly. And we've talked about this in previous videos, but the key is if you're going to have a lot of tools, they need to be distinctly different. They can't be somewhat similar. If they are, then the AI will likely choose the wrong one like a human would. But to avoid that altogether, I recommend avoiding using too many tools. And the approximation we can make here, the assumption here is that the more tools we have, the more errors we're likely going to run into, which means we're going to have more failures. So you want to start small, and that's really the premise here is we need to ship narrow. So the MCP itself should be a very specific part of a larger workflow that we think is too chaotic, where we should put an AI inside of that to assist with the chaos and the variability of that specific part of the workflow. So it's a narrow shipment inside of that thing. And then the next one is ensuring the tools are well named and they're different. So not just well named, but also different from each other. So if there are tools that are somewhat similar, you don't want to have them attached to the same AI. And then lastly is ensuring that we're enabling the ability to dynamically discover these tools. So it's only pulling in tools that it needs at any given time. And that's based off of previous infrastructure you set in place where you send a question to it, it understands the context, and then it diverts and gets the right tool at the right time. Use a few tools, not too many, and keep it narrow. Use well-named tools and then allow it to pull those tools in dynamically. That's the first rule. The second rule is to talk to A like a human. So talk to it like it's a human. Reason being is that it's trained like it is a human. So you can't necessarily send it all types of things, and that's what we've broken down here. Outside of just calling the tool itself and getting it to, pull the function that it needs to do for the call, when you respond with information associated to whatever context it needs to not just call the tool, but do the action, you should use Markdown instead of massive blobs of JSON. Reason being is that the AI itself isn't necessarily going to be able to comprehend this as effectively as it would do as Markdown because it's trained on human language. So treat it as such. Next is speak to it like it's a human. Don't send it strictly just a bunch of error codes because it might not necessarily know what these error codes mean if you've not given it that right context. So in that case, you should give it, say, we've ran into this error for this reason. This is likely what's happening, et cetera, et cetera. So it should be more human oriented. And then lastly, be concise. So concision is key, especially if you don't want to waste money. Oftentimes, if you have an AI that is calling tools incorrectly or is calling too many tools, you're going to waste a lot of money because the tool call in itself, depending on the model you're using, you could have one question cost $10. And that's pretty pricey depending on the type of business you're in. So that's the second rule. Talk to it like it's human. Next here is plan for chaos. Assume that your AI is going to behave in erratic and chaotic ways. And there's a few things we can do to constrain that chaos. First is setting limits on the number of tools that it can call. So we should, for similar, so if you've used Cursor, Cursor has a limit of 25 tool calls unless you're using max mode, and then it can go crazy. And I've experienced it spending too much of my money going crazy in max mode. So it has limitations saying you can call 25 tools, that's it, and then we're going to prevent you from going forward unless a human is inserted in the loop and they approve you to move forward. So set limits on number of tools. You want to log as much as you can so you can go back and see exactly why it failed in calling a tool. So you might be able to fix that issue in a systematic fashion in the prompt or how that call for the tool is being named. Next is timeouts. So if a AI is calling a tool, it may call that tool in an extended period of time. So instead of just calling one, it takes forever that for that tool to respond or for that AI to effectively get the response out of that tool. So you want to ensure that you're not necessarily sitting there for too long and allowing it to cut off if it's taken too much time. So those are a few ways you can kind of plan or avoid too much chaos. Our fourth and final rule is locking down dangerous stuff. What we mean by dangerous stuff are the dangerous actions that I mentioned previously. So that could be deleting or inserting or doing some form of action that could potentially harm your business's overall revenue, brand, customer experience, etc. And a few things we can do to lock down those dangerous actions. First, and probably the most important, is always adding a human in the loop, especially for anything that's a critical action. There should be a human that approves both the action being taken as well as the output from the AI before it goes to the customer or somebody else. Next is use authentication. So ensure that you're using the right authentication for the tool and don't just use standard error. I think it's standard in and out. That's the common thing that people use for local MCPs. Don't use that. Use the proper SSE or I think the new one's the streamable one for HTTP. And then the next one here is only share what's needed. So if it's calling a tool and it's sharing back information with the consumer, make sure it's sharing only information that consumer should have access to based off of privileging and permissions. And our final one here is assuming the worst. So this is assuming that the AI is going to go off the rails and take the most crazy actions that it could. And if so, we need to ensure that we have everything else previously set up, as well as other things to ensure that if it does take crazy actions, it's not going to have a big impact on the business. Those are the four rules for building with MCPs. Now, the next one here is what needs to improve for us to have more faith in this AI and be able to use these different AI agents more effectively with MCP tools. There's a few things. So first, like as you can tell from all the things that I mentioned previously, is tool calling. So tool calling is likely the most important thing that we need to improve. So what do I mean by this? The the effectiveness of an AI varies based off of how complex the ask is and how many tools are needed for it to achieve that task. If it's more complex and there are more tools, it's likely going to have a higher failure rate than it would if it didn't. So if it's just calling one tool for a simple question, it's likely going to get it almost every single time. If it needs to call five tools for a complex question, it's likely going to fail most of the time. This will change over time. So, what we need to watch is how it performs on different benchmarks that track the multi turn tool call situation over time for different models. This benchmark here is one of the most prominent when it comes to multi turn interactions for tool calling. And down here, you can see that the top ranked one of all the different tools, when it comes to long context, which most real world use cases will have, is performing at 74%, meaning that 16% of the time it's failing. And I'm not sure about you, but I know most businesses wouldn't really accept a 16% failure rate for any type of action that's critical and or customer facing. And that needs to improve, and I'm sure it will, like I said, over probably a few months, 3 to 6 months. Just another example of increased complex tasks. So this is from Anthropic's blog where they were testing Claude 3.7 Sonnet on a specific benchmark, which I think is called Tau Bench. And this is Tau Bench. They have two different use cases. I think this is airline, and the other one I think is retail. And they increase the complexity of the task as well as the number of tools that are needed. And here you can see their extended thinking model. So the smartest one using up to five tools has a 16% success rate for doing this specific task, which I think is booking a flight on an airline to a certain location over a certain time within certain constraints. And 16% of the time it succeeds. So that's not a failure rate, but success rate. My assumption is that the tasks for this multi turn test in long context is nowhere near as complex as this. And the important thing is this right here is what humans like you and I want these AIs to do. We want them to do more advanced use cases that include multiple tools. So if you want to have true value to provide to your consumers, you need to have models that are effectively doing this at a high accuracy rate. Right now, they're not there. And I know this is 3.7, but I'm sure if Cloud 4 and Gemini 2.5 Pro, they're likely higher, but I don't know if it's, 100%, like, 80% higher or whatever else. So that's the first thing is multi-turn tool calls. We need to track that benchmark. The next one is memory. So we've talked about over here really quick. I mentioned the context, long context in this section here. Well, long context is a common thing that a lot of these AIs will have to deal with because they have to have a memory associated to the person they're speaking with and all the associated information we're going to shove into their head. Meaning that the amount of data we put into their head is likely going to be a lot higher than just 192,000 tokens. It could be that high. My assumption it'll be, probably a lot higher, not just for what we've put into it from a consumer's perspective, but also all the associated data from the tools that it's calling. And you can see that for Fiction Live Bench is a benchmark I've talked about a lot here. The ability for the AI to reference different information over a long memory span has improved drastically. So you can see as we increase the amount of data, it's sustained the accuracy. But once we get to 192.03, drops to 58. 2.5 Pro, the newest one, does a pretty good job getting up to 90. And if we go down here, we can see Claude 4 actually does a really bad job. It goes down to 37 and 36 after it expands up to these higher memory extensions. So the important thing here is we need to have AIs that can sustain their ability to reference different types of data over a longer time span. So when it's calling tools and referring back to previous tool calls and trying to do a complex task, it can do that likely 100% or at least 95% of the time. So this is just another benchmark we need to track for the associated use of AI agents in MCP. And then last thing is reasoning. So this is humanities last exam. So this is something that was put together by a bunch of different people, and the scores here are relatively low. So this is like 21.64, and these are really hard questions for reasoning abilities. But the ability to reason is important in the context of calling tools, because if you can reason on which tool to call in which context, and that context is expanding in complexity and the number of tools you can call is expanding, that means that you're able to call the right tool irrelevant of how complex the task is. So higher reason, better use cases. And here you can see that Gemini 2.5 Pro is the top one with a 21. We have O3 high, and then if we kind of keep looking through here, we can see Cloud 4 Opus is pretty low, and a variety of others. So either way, even high is still low at 21, and I'm pretty sure that's out of 100. So this would likely be a lot higher, so we can have more trust in these tools when they're using AI agents and MCP. So these are some benchmarks we want to follow. Now, where is this working? Because MCP is obviously it's not all just hype and all that stuff. It actually is being utilized effectively by people. And one of the primary, or probably the only use case I've seen it having serious success. And when I say serious success, I mean in the context of production scale things that a lot of people are using, they're getting a lot of benefit from, is code. So here we have Cursor, here we have Windsurf. And the primary reason that coding is the use case that has kind of skyrocketed for MCP, and there's probably many different reasons, but one of the reasons is the constraints that code provides to MCP. The first thing is code provides a very clear structure that the AI can follow. It also provides errors, and those errors are immediately visible and easily fixable based off of what the AI can see. Also, the AI can review the code or even the tool call before executing. And then the feedback loop is really tight because of these things here. So with coding, it's a very structured environment. So we know what the right answer is based off of tests we can run and everything else. So with code, it's much easier to call MCP tools and utilize them in this context, but also the human is in the loop, so that the developer that's looking at this, they can approve or deny the call of the tool or the response from the tool call itself. So this is the primary use case and the reason as to why code is kind of the primary area that's so successful. Some use cases that are outside of code that I'm starting to see a lot of use in is customer service, not resolving questions, not answering things and fixing them, but triaging those questions. So you get a question in, you triage what specifically the potential issue is and the potential answer is. You then pass that off to a human or validate that through some other system before responding. And there's different types of stats that I've seen thrown around where different people have tested these tools with AI agents, and they've seen that by adding MCP tool calls with agents, they've increased their success rate of triaging questions up to 90%, up from 60% without tools. And the big one here is research. So this is probably the biggest use case outside of code where I've seen MCP tools being used most frequently. And that's where you have an AI runs off, calls a bunch of tools to pull different information from different resources. And you can think of deep research from OpenAI or Grok or Perplexity or Claude or Google. All of them have it. They're using deep research as a starting point to show and prove the benefits of MCP. And My guess is that recently OpenAI's new connectors for the business plan is going to prove this out even more economically because a lot of businesses are going to get more value from deep research when it's on their internal data sets and not just on the internet. So that's the emerging use cases and where MCP is useful today. Now, the next one here is how are companies making it work? So, if I'm using MCP in production with a business, how are they making this useful? What kind of patterns and structure are they using? So, the first one here is a hybrid approach. Very rarely do you find anybody throw an entire workflow at an MCP agent and say, do this entire thing. Instead, they're doing a hybrid. So they have some code and then they have some AI agent doing something, but that something is probably minor, small, and contained. So they're doing both. And if they're doing both, this is kind of the ratio I've seen pushed around and shown, where you first have something that like a routine task. So the routine task inside of this overall workflow, because everything here, so all of these are inside of one big workflow. And the first part of this is the majority of the workflow is routine, something that can be done through a code and it's handled perfectly. So that's 80%. Then there's a 50% of this that's complex, it's adaptable, it changes over time, and it's hard to determine what's going to happen. If that's true, then 15% of that is going to be routed through an AI with MCP tool calls. And then the last one are the edge cases. And these edge cases that can't be handled here and or can't be handled here, we're going to throw those to humans. And those 5% edge cases are going to be tossed off to them and help them. So this is kind of the approach that I've seen people use, the hybrid approach when comes to AI agents and code and the associated tool calls. Another thing I've seen a lot of people do is the validation sandwich, where you have an input from either an AI or a user, and you have code validating that input to ensure that it's either the right question to be asked and it has the right data sets. It validates everything that's inside of it. There's different ways you can validate it, but there's some sort of code validation in the beginning. Once they do that, they then pass it off to AI that processes what's being discussed or shared. The AI processes it after it's done. Then it has another code validation step where it validates the output is in line with what's expected. And then you have the output. This is a very common structure. You have a lot of agents that are especially chat based, but I've also seen this with automation workflows as well. And here's just a simple example I pulled together. So, a simple example for expense reports. So, here we have first, we have the code that validates that the format of the receipt is valid and the amount is valid because we can do that with code. Next is AI is going to extract out the information from maybe a receipt with OCR or some other form of vision recognition. And then we have a categorizing of the data. So we try to add this into categories that fit within what matches for our tax purposes. So after you've done this, then you have code validate and verify that the total is correct based off of what the AI pulled out and it's compliant with the categories they already have. So whatever category you've chosen here, I need to make sure that it matches. And then last, we pass it off to a human to approve. Since this is an expense report and it's a key thing, we're always going to pass it off to the human to approve. So that's the example for the validation sandwich. And then if we look at both of these, there's a common pattern between the two of them, and I wanted to call that out here that I think encapsulates the both of them. And I've already talked about this quite a bit. We'll hit it one more time, which is first is limiting scope. I've said it once, I'll say it again. We're not throwing an AI agent at the entire workflow. Instead, we're giving it a well-defined task, ideally a subtask, and something specific that the MCP can handle. And that specificity is based off the constraints I mentioned previously. So it's adaptable, it changes, etc. Next is both of these have humans in the loop. So we always have some sort of human in review, especially for those critical decisions that matter to the business, the brand, etc. And then lastly, there's always some sort of fallback system. So if everything else fails, we can always fall back to a traditional method of how we've done this before. And if we don't have a traditional method of how we've done this before, then again, we fall right back to a human. So this is kind of the core pattern that I've seen between both of these and also different conversations I've had with people with use cases that are in production. In the end, I want to leave you with something positive. So I know that we've talked a lot about different types of reasons as to why MCP isn't there yet today, but it will be in the future. And it's important for us to be aware of what's happening, utilizing the tools, learning the different tactics and structures, but realizing that it's not ready for production yet, at least for most use cases. And the final thoughts I want to leave with you here are that if you're a developer, you should be experimenting. You should be experimenting with all these different tools and understanding how to use them. So experiment as much as possible. If you're a small to medium sized business, I'd recommend just waiting 6 months. unless you have a very specific use case that fits MCPs perfectly. So like like I said, if it's code or something else, yeah, sure, try it. But if not, I'd probably just wait it out until the models get to the point where they're more reliable and also the infrastructure is built out more. And then lastly, if you're a large enterprise and you have both the resources, time, and money, etc., then you should start small with minor use cases that you know are okay to fail. If that's true, then you can start playing around with these. But outside of that, I wouldn't get too gung ho about using these MCPs. And internet. With that being said, I hope you found this entertaining, educational, all that stuff. If you did, reshare it with your friends. And if you'd like to work with me, I have a company called Gradient Labs, where we help other organizations implement AI internally to automate different processes, saving time, money, and sometimes generating revenue. If that is at all interesting to you, below is a link that you can book a free discovery call to see if there's a good fit between the two of us. And with that being said, internet, I'll see you next time.